subject AC machines to topic is single phase commutator motors. So here the objectives are of this period you would be able to understand the principle of operation of stepper motor. Principle of operation of stepper motor. So now go for introduction. Stepper motor is an electromechanical device. That means it is convert this met this stepper motor converts electrical energy into mechanical energy. It is the stepper motor device which actuates which actuates a train of step movements of shaft in response to train of input pulses. So here a stepper motor is an electromechanical device which actuates a train of step movements of shaft in response to train of input pulses. The step movement may be angular or linear. The step movement may be angular or linear. There is one-to-one relationship between an input pulse and step movement of the shaft. There is one-to-one relationship between an input pulse and step movement of the shaft. Here, each pulse input actuates one step movement of the shaft. Each pulse input actuates one step movement of the shaft. Once again, the introduction is a stepper motor is an electromechanical device which actuates a train of step movements of shaft in response to train of input pulses. The step movement may be angular or linear. There is one-to-one relationship between an input pulse and step movement of the shaft. Here, each pulse input actuates one step movement of the shaft. The principle of operation of variable reluctance stepper motor. The operation is based on various reluctance positions of rotor with respect to stator. The operation is based on various reluctance positions of rotor with respect to stator. When any one phase of the stator is excited, it produces its magnetic field whose axis lies along the poles, the phase around which is excited. When any one phase of the stator is excited, it produces its magnetic field whose axis lies along the poles, the phase around which is excited. Then rotor moves in such a direction so as to achieve minimum reluctance position. the rotor moves in such a direction so as to achieve minimum reluctance position. The minimum reluctance position means a position where axis of magnetic field of stator matches with the axis passing through any two poles of the rotor. So here the minimum reluctance position means a position where axis of magnetic field of stator matches with the axis passing through any two poles of the rotor. Any two poles of the rotor. Let us see the operation when phases A, B and C are energized in sequence one after the other with the help of switches switch 1, switch 2 and switch 3, that is shown in driving circuit. So let us see the operation when phases A, B and C are energized in sequence one after the other with the help of switches SW1, SW2 and SW3 shown in driving circuit. See here, see here, this is the stepper motor. See here, here this is the stator and this is called a stator magnetic axis, and this one also stator magnetic axis, and this is also stator magnetic axis here, this gap, and these are the rotor poles 1, 2, 3, 4. Here this stator magnetics and the rotor poles, these 1 and 2, 1 and 3 poles, see here both are coincides at the same along the same axis. At theta equal to 0 degrees, when the phase A dash is excited with the switch SW1 closed, then stator magnetic axis then stator magnetic axis exists along the poles. See here the stator magnetic axis, this is the stator magnetic axis. Here this rotor poles, so here the rotor poles are 1 and 3 form here exist. The phase when the phase A dash is excited with switch SW1 is closed, then stator magnetic axis exists along the poles formed due to A dash vertical. Here next one, then the rotor adjusts itself in a minimum reluctance position, that axis of rotor poles 1 and 3 aligned with the axis of stator poles. Here 1 and 3, this is the 1 and 3 poles are aligned with the stator axis of the poles. Here A dash, stator axis of the poles. Then rotor adjusts itself in a minimum reluctance position. Axis of rotor poles 1 and 3 aligned with the axis of stator poles of A dash is shown in figure. See here, at theta is equal to 30 degrees. At theta is equal to 30 degrees. See here, at theta is equal to 30 degrees. Here the faces are B dash, and this is excited, and here A dash is de-energized. So here the rotor poles are 2 and 4 along with the BB faces. That means stator poles BB dash side. So when the face BB dash is excited and the face A dash is de-energized, then stator magnetic axis shifts along the poles. The stator magnetic shifts along the poles formed due to BB dash shown dotted in the figure. Theta is equal to 30 degrees. Then rotor tries to align in the minimum reluctance position. Then rotor tries to align in the minimum reluctance position. The rotor poles 2 4 or 2 4 or 2 4 are nearest to the position of alignment. The rotor poles 2 4 are nearest to the position of alignment. Therefore, the rotor moves to align the axis of rotor poles 2 4 with the stator axis. This causes a rotation of 30 degrees anticlockwise. Therefore, the rotor moves to align the axis of rotor poles 2 4 with the stator axis. This causes a rotation of 30 degrees anticlockwise. 30 degrees anticlockwise. The point P shown on the rotor has rotated. The point P shown on the rotor has rotated through 30 degrees in anticlockwise direction. So now here theta is equal to 60 degrees. This is for theta is equal to 60 degrees. See here, observe this one. Observe this one. Here this A, this is A, B are de-energized, and only C and C dash, this is the excited. Now here the poles are along with the, so the rotor poles are 1 and 3 along with the stator axis. So now at theta is equal to 60 degrees. So when the face C dash is excited and the faces A dash is and B dash are de-energized, then the stator magnetic axis shown in the figure. Then To achieve the minimum reluctance position, rotor turns through further 30 degrees in anticlockwise direction. Anticlockwise direction. Hence point P is now at 60 degrees from its starting position in anticlockwise direction as shown in figure. By successively exciting the three phase in the specific sequence, the motor takes 12 steps to complete one revolution. By successively exciting the three phase in the specific sequence, the motor takes 12 steps to complete one revolution. Here, here the characteristics, that means the characteristics in stepper motor is between the torque plus current. So here the stepper motor, in generally it is a series motor. So that is, here the torque developed by the motor which acts on the rotor is proportional to the square of the phase current. The torque developed by the motor which acts on the rotor is proportional to the square of the phase current. Torque is proportional to I square. Torque is proportional to I square. The direction of rotation is declared from the sequence in which the phases are excited. The direction of rotation is decided from the sequence in which the phases are excited. Once again, see here, reluctance stepper motor. Here, in this case, at theta is equal to 0 degrees, so it is stator axis and these poles are excited, remaining is de-energized. These are excited, remaining is de-energized. So here the stator magnetic exist along the poles formed here 1 and 3. These are the 1 and 3 along the stator axis, and theta is equal to 0 degrees. Now at theta is equal to 30 degrees, so B dash is stator axis and 2 and 4 along this stator axis. So this is theta is equal to 30 degrees. Only B dash is the energized, the remaining poles are de-energized. That means B dash is excited, remaining is de-energized. Here also, see here, at theta is equal to 60 degrees. At theta is equal to 60 degrees, see here, the axis here, the stator axis C dash, and the poles, rotor poles are 1 and 3. Rotor poles 1 and 3. So here it is rotated. It is rotated anticlockwise direction, that is 60 degrees. It is 60 degrees. Now see here, the summaries we have discussed in this class about the principle of operation of variable reluctance stepper motor. The principle of operation of variable reluctance stepper motor. Thank you.